everyone, and thank you for tuning in this evening. I'm Dakota Smith.
And I'm Meredith Fish. Dakota, we have an exciting show planned, as this is your last one here at Penn State.
Yeah, I really can't believe it. It's my last show, and it's going to be a great one. We'll start off with a climate feature covering the dynamics involved in sea ice freezing and melting.
Plus, we'll have another report from our weather communications class exploring the interactions between universities, the government, and private businesses in the weather enterprise.
But first, let's get to the latest news and information from the weather enterprise and climate science world. Here's this week's Update in the Air.
A new study has some unsettling news for residents of New York City. Water rising in the New York harbor due to storms is now 20 times more likely to overtop the Manhattan seawall than 170 years ago. This comes from a combination of sea level rise and storm tide, the amount of local sea rise during a storm. With those two inputs, the odds of stormwater spilling over Manhattan's seawall is once every 4 to 5 years, compared to once every 100 to 400 years in the 19th century. During Hurricane Sandy's storm tide at Battery Park reached a record of 14.06 feet, according to the National Hurricane Center. Total damage in New York City estimated to $19 billion, with at least 21 people killed by storm surge on Staten Island. While the rise in sea level is attributed to the expansion of warming ocean waters and ice melt, the cause of the rise in storm tide is not yet clear.
A United Nations report says greenhouse gas emissions from agriculture could be cut by 25 to 40% if Europeans cut their meat and dairy consumption in half. Although it's hard to change people's eating preferences, Professor Mark Sutton says it's not about whether you eat meat or dairy, it's about how much. The number of imported soybeans, often used to feed livestock, would decrease by 75%. Freeing up the land for growing cereals or biofuel could make the European Union a major exporter of products instead of a major importer. However, one must not forget the steps that British livestock and dairy sectors have taken to reduce their greenhouse gas footprint. The Department for Environment, Food, and Rural Affairs says we're working with farmers to reduce greenhouse gas emissions to help farmers become more environmentally sustainable. Only the executive summary was published this past Friday. The full report will be available next month.
For many episodes now, we have commented on California's drought. Well, now every inch of the state is experiencing some form of drought. An area on California's southeastern border was the only holdout for the state. But now even that part is considered abnormally dry, and for the first time in the 15-year history of the Drought Monitor, the entire state is now in drought. Throughout 2013, some form of drought persisted throughout the state, but this past winter has led to an explosion of drought. In mid-January, the middle of California's supposed rainy season, extreme drought covered 65% of the state as rain and snow failed to produce. The most dire drought category, exceptional drought, is now encompassing nearly a quarter of the state, most in the Central Valley, a prime growing region in the state. With the rainy season mainly over, drought is expected to persist or worsen throughout the summer.
For the first time in human history, April will record atmospheric carbon dioxide levels higher than 400 parts per million for the entire month. Since 1958, carbon dioxide concentrations have been measured at Mauna Loa Observatory in Hawaii, showing how far concentrations have come from the original level observed of 280 parts per million. Jason Smrdan, a climate researcher at Columbia University, said, "The upward march is neither surprising nor unexpected. It is only alarming in the sense that it keeps happening unabated. Levels will continue to rise throughout May, which is typically seen as the peak of carbon dioxide in the northern hemisphere. Now it is only a question of how long will the carbon dioxide levels stay above 400 parts per million this year."
Up next, we have a feature from Penn State's weather communications class.
Ryan Bells and Matthew Koval will explore how universities, businesses, and government interact to bring us the best weather information.
What does the Weather Channel, the National Weather Service, and Penn State all have in common? They are all a part of the United States Weather and Climate Enterprise. The U.S. Weather and Climate Enterprise is the unique interdependent relationship between government, industry, and academia that provides weather and climate services in the United States. These three sectors, including help from the general public, help this enterprise to not only provide better weather data, but also to protect life and property.
The first sector of the enterprise, the government sector, is in charge of collecting and processing weather data. Using this data, the government sector provides weather prediction models and forecasts using high-performance computing. Finally, the government sector issues service weather watches and warnings for the United States and its territories. The government sector can be traced back to 1870, when the U.S. Army Signal Service was established. After being renamed to the U.S. Weather Bureau in 1890, the name changed once again in 1970 to what we now know as the National Weather Service. The second sector of the enterprise, the commercial sector, is commonly known as the face of the enterprise. The commercial sector is about communicating and interpreting the forecasts and data from the government sector and relaying that information in easy-to-understand format for the general public. The commercial sector, which includes such companies as AccuWeather, The Weather Channel, and Weather Nation, are generally portrayed as the face of the enterprise and meteorology due to their extensive public presence. When someone asks you to picture a meteorologist, they imagine their local television meteorologist standing in front of the green screen, relaying their weather forecast. The commercial sector is the youngest sector in the U.S. weather and climate enterprise. Private meteorologists did not hit the radio airwaves until 1926. It wasn't until 1949 when private meteorologists took to television to provide forecasts.
The final sector in the U.S. weather and climate enterprise is the academia sector. This sector trains future meteorologists and scientists for the commercial and government sectors. It also provides research for those sectors that can further expand our knowledge about weather and its properties. Although these sectors have been in existence for a long period of time, there hasn't been a clear definition of the U.S. weather and climate enterprise until 2003. The Fair Weather Report, published by the NRC, defined the weather and climate enterprise. It also gave recommendations to this enterprise on not only improving forecasting, but also further developing communication and cooperation amongst the sectors. So whenever you receive a weather alert on your phone, understand that it is not just a single source that is looking out for your well-being. It is an entire enterprise that is trying to keep you up to date with the ever-changing weather conditions. For Up in the Air, I'm Ryan Bells.
And I'm Matthew Koval.
And up next, the Climate Dynamics class here at Penn State will be joining us.
That's right. Corey Barwart, Catherine Menke, and Lacey Morrow will examine sea ice melt and how this may impact our coastlines.
Sea ice. Frozen water that forms, grows, and melts in the ocean. It should not be confused with glaciers or icebergs. Since 1972, scientists have been using satellites to measure sea ice extent, area of ocean with at least 15% sea ice coverage. Sea ice thickness and the extent of summer sea ice have been declining dramatically since the 1980s. In the Arctic, sea ice is a major force in keeping air temperatures cool and overall moderating the global climate. Changes in the amount of sea ice alter how cold the poles are, which can affect the atmospheric and ocean circulations. Because of this, the Arctic is very sensitive to climate change. The surface of the sea ice with snow cover has a high albedo of 0.8. This means 80% of the sunlight that strikes its surface is reflected back to space, with only 20% of it absorbed. In areas where the ocean is exposed, the surface is very dark, almost black. This has a very low albedo of 0.1, which means when there is a lack of ice coverage, 90% of the sunlight is absorbed by the ocean, raising the ocean's temperature and changing the planetary radiation balance. This will enhance the regional and global warming process. This warming of the ocean's temperature will also cause thermal expansion to occur, and since warm seawater has a greater volume than cold seawater, the total volume of the ocean will increase, causing the sea level to rise. Also, as atmospheric temperatures go up more and more, ice and snowfields will melt, increasing the amount of water in the oceans and therefore causing the sea level to rise faster than by thermal expansion alone.
Over the past century, the global mean sea level has risen by 4 to 8 inches. While it is hard to pinpoint how much the sea level will rise, most predictions agree that the oceans will rise somewhere between 2.5 to 6.5 feet by 2100. An increase in storm surge is another aspect of sea level rise that will affect low-lying regions. Rising sea levels will make it more favorable for smaller storms to cause huge amounts of damage with storm surge, and larger storms can make the 100-year flood occur every 5 to 10 years. Warmer ocean temperatures will likely help strengthen some Atlantic hurricanes, so while there might be fewer hurricanes, they will be stronger. Sandy is a great example of all these aspects coming together. Abnormally high sea surface temperatures in the Atlantic helped intensify the storm, as well as allowed the storm to stay strong after it left tropical waters. The storm surge with Sandy occurred at high tide, which is a good example of what normal storm surge in the future could look like. Low-lying areas around the globe will also be threatened by beach erosion, landslides, and contamination of freshwater supplies. So what is being done to cope with rising sea levels? In Louisiana, the levee projects are being designed to anticipate an increase in sea level over the next 100 years. The problem, though, is Louisiana is sinking as sea levels are rising. Regionally, the sea level has risen 8 inches in the last 50 years, slightly faster than twice the global rate. In the United Kingdom, the Thames Barrier was built to protect London from flooding due to exceptionally high tides and storm surges. The barrier was designed to withstand floods that occur only once in 1,000 years. Both rising sea levels and more extreme weather, the barriers need to be redesigned. Melting sea ice will change our planetary radiation balance, causing ocean and atmospheric temperatures to rise, as well as sea level. By 2100, the oceans could rise another 3 feet, causing storm surge and flooding to become more powerful and destructive. Many cities are already starting to prepare for this fate, but it is still unknown if this will be enough. For Up in the Air, I'm Catherine.
I'm Lacey.
And I'm Cole.
Catherine, Lacey, and Corey, thanks for a great report.
And staying on the climate theme, Ryan is now in the studio with next week's Climate Outlook.
So Ryan, we've had a fairly nice weekend. However, rain has spoiled the majority of this week. So what can we expect looking forward?
That's right, Dakota and Meredith. Thanks very much. It certainly was a nice weekend last week, but we really turned the corner this week with gloomy, cool, and kind of damp weather here in Pennsylvania as well, with quite a bit of rain through the middle part of the week. Let's take a look at what went on last week throughout the nation. This is radar-derived rainfall or precipitation totals through Monday, and this includes a lot of the severe weather that occurred to our south and west on Sunday. Of course, a devastating tornado situation in places like Arkansas and into parts of Missouri last weekend. Now, some of this moisture moved into Pennsylvania here on Monday, Tuesday, and Wednesday, but the story heading into the west is that it's remained quite dry. Last week, another 4 corners. Not the case, though, here through the Pacific Northwest, where a couple of places received 3, 4, or 5 inches of rain last week. As far as going forward, our temperature outlook for next week, this is May 5th through the 11th. The beginning part of May appears it'll feature overall below normal temperatures here through a lot of the Northeast and Mid-Atlantic. However, the core of the cold, and again, this is relatively speaking, comparing the temperatures we're expecting during this period to the average temperatures during this period, it'll end up being much below normal, we expect, through the northern part of the Midwest, up through Minneapolis, St. Paul as well. While through the west, we are expecting above normal temperatures, although it doesn't appear any extreme heat is on the way. Some places along the California coast and down toward Mexico as well may average well above normal into next week. In terms of the precipitation, we certainly had quite a bit of it this week. Well, the overall view is that we may continue to see above normal precipitation next week coming in terms of waves. We don't expect any sort of major weather systems, and at the same time, like we saw last weekend, any big severe weather outbreak can certainly cause quite a bit of rain in a short period of time in a given location. Through the west, not a lot of below normal precipitation areas, really just down here through New Mexico, Arizona, and the southern part of California, and it does appear that the rain will continue to move through the Pacific Northwest as we head into next week as well. Now, this, of course, is the final episode of this semester, so that is the final Climate Outlook, but it is also Dakota's last episode here and Up in the Air, and on behalf of everybody who has been a part of this, Dakota's been a part of it for 3 semesters and was one of the beginning hosts here of Up in the Air. So we certainly wish you well, Dakota, as you head off to Colorado State next year for grad school. We will miss you around here.
Thank you, Ryan, very much for those kind words.
And Dakota, this is so sad for us here on Up in the Air, but what are you looking forward to in Colorado?
Well, I'll be working with a climate biosphere model, and I'll focus on the interactions that grasslands have with the lower atmosphere. And I'm hoping to improve the model to improve our forecasts of our climate.
Well, we look forward to your updates, and maybe you'll be featured on the show.
Well, wouldn't that be something? Well, thank you all for a great year and a half. I've thoroughly enjoyed my time here on Up in the Air.
We are all thoroughly going to miss you, both on Up in the Air and around campus. Thank you all for tuning in. That's going to do it for tonight. I'm Meredith Fish.
And I'm Dakota Smith. Whether it's on the show or in my research, I'll always be up in the air.